Hi friends, this is my first video on Ansys. Okay, here I can clearly explain about the Ansys and how it's working and what are the procedure and everything. So in this session, I explain about the Ansys. Okay, being a mechanical engineer, so we design a model in modeling softwares like Creo, CATIA, NXCAD, Inventor. So lot of software. So after completing software, we give the drawing for manufacturing. A process in between modeling and manufacturing is called analyzing. So we need to analyze our model, it withstand the temperature or the force, okay, or the frequency, everything. So for this process we're using the software called Ansys. Okay. The Ansys, the basic workers has our subject. Okay. The many industries are using the Ansys software, okay, for checking the model. As a design engineer also we have to basic knowledge about the Ansys. We have basic knowledge because then only we can identify is the model is which stand with the load. So in this, the Ansys is a very basic software which perform the static analysis, vibration, and fluid dynamics and heat transfers. That's called thermal analysis and electromagnetic analysis. So these are the basic things which can be done in the Ansys. Okay. Already we know about the fluid. That means the CFD. So these are the steps. So in which the Ansys is the majorly working on the FEA analysis. FEA is nothing but the fand element analysis that we already studied in the engineering. So the basic concept, when a bigger body is cut into small pieces, in small pieces we calculate the stress and integrate it one. So this is the basic method. For example, in case we have some rod and we cut it into small pieces. So that small piece is called FEA. So on that basis, we have to calculate the analysis. Just cutting small pieces and we integrate the whole body. Okay, and basically there's a three step for analysis. One is a numerical method and calculation method, that's called calculation method. Second one is a real-time method, and third one is a that model based analysis, the FEA method. So the main benefit of the FEA is in calculation method we have done the calculations already. We studied the SOM, strength of material. So there is a study about calculation for stress, strain, and these are the calculations we have done by our own. So it takes a lot of time. Okay, so that one method. Another one method is called real-time method. Real-time means really we produce a prototype and we manufacture a prototype and we undergo the process for the maybe static or model anything process for check the behavior of the model. So each and every time we can't design the prototype and give the force and load. So it takes too much of time and money and everything. In numerical method we can achieve 95%. In real time we can achieve 97 to 98%. So in combining those two is called FEA. So we can run the model in 3D modeling software and we import in the FEA, that software Ansys or anything so FEA software. Then the calculation we done in the SOM is already feed in the FEA, that called stiffness matrix. So that we can simply use it, that we can get our result accurately. Accurately means 90% up to, because there's some lag in there. So this is the main benefit of the FEA. We can reduce the time and we can testing the prototype many times with the different materials. Okay. These are the major benefits in the FEA. So in upcoming class I can explain how to split and what are the types of splitting, that everything. Okay, and this is a major performance in FEA. Next that we go for the analysis area. The major areas are static, structural, multi-physics, embedded, fluid and semiconductor, electromagnetic. So this is a major role in analyzing area. The static section and body in the rest we can test the behavior. Multiphysics can link with the static to model to thermal like that. So embedded as like it, and fluid CFD is a major play role like aerodynamics and semiconductor. So that's a flow and that start and points are correct or connections are not. That's everything you can test that. And finally electromagnetic. Electromagnetic is nothing but the waves, vibrations and the electronics. So these are the things we have to these are things covered in the Ansys area. But we majorly focus on the static sectoral. Okay, because everybody we undergo on the static sectoral, then only we can get the exact result. It's workable or not everything. For a first example for static sectoral, we go for the cantilever beams. Already we study the cantilever beam, simply supported beam like that. Here for example, just I show some images, and here that we can check that. So in this one we just see one end is a fixed and in the other end we give the force. Okay, like that we can test cantilever beams and simply supported beam with this support. Okay, next we go for the next analysis. So next analysis we go for the thermal. So in thermal, is three basic concepts called conduction, convection, and radiation. So convection is nothing but among same body or same fluid. Conduction is nothing but so transferring one body to another body with the contact. In radiation means without contact transfer to one body to another body. So in thermal we can basically use the fins type. Okay, in every motor and every heat component we can see the fins. The major work of the fin is ex dissipate the heat from central body to one body to another body, the conduction process. So these are things we have done in the thermal analysis and study about the heat transfer and everything. Okay, this is a major thing, and see the picture and below. Then we go for the CFD. So already we know about the CFD. So that's the basics. It's nothing but aerodynamics. In everybody we can check the aerodynamics is the correct or not. If the flow is going up or not, like lift, drag, weight. So these are the basic concept in CFD. We must know about these four things: lift, drag, and weight. Okay, these are the main thing that we have to study. So this is the best example. Okay, you can see in the picture how the air is flowing along the car. So like the ships and everything we can study in the fluid dynamics. Then we go for expertise dynamic analysis. It's nothing but the crash analysis. Like when one car is hit on the wall or car and hit on the car, there's a damage. Or like when bullet hit on the bulletproof. So what type of behavior that undergoing? So that we can study in the expertise model. Simply that we can't didn't waste a number of the car. We just do in the model like this. When the bullet hit on the some plates, what happened for the plates and how its reaction. So that we easily can study it. So apart from that, this is a very basic concept for PLM, product life cycle management. So how the product gets started and how it's undergoing and what are the procedures they are processing. So in this example, we can use this flowchart, then we can clearly understand the product life cycle. Here is the first of all our customer. Our customer is a requirement. On the base of customer requirement, we have designed for the concept, right? Freehand sketch. So then completing freehand sketch, we go for the 3D model. Like any software, CATIA, any software, we design the 3D model on the base of the concept design. The concept design we use for the calculations and catalog everything. After completing the 3D model, we go for the validation. For the any type of analysis, we doing that. So after completing the analysis, we go for the drafting and detail engineering. So finally, after completing this, to go for the manufacturing. So after completing manufacturing, again go for the customer. We get the feedback. Nothing but in case at the yearly time, the car has only not too much fast or not too much design. Okay, but now it's totally changed. There's too much of design and too much of speed. So this is our customer requirement. When you complete a manufacturer and go sell on customer, they again give some feedback. So we collect the feedback. On the feedback, create the concept design, and again 3D model, again validation, again drafting, so again manufacturing. So again we send this to customer. So these are accommodating the planning and management. Okay, this is called PLM. So ANSYS are mainly work used in the many industries like Samsung's, Audi, Metron, Airbus. Okay, mostly major companies are using ANSYS. Why? Because means it is a user friendly. Okay, friends, we wind up with this session. Next session, we explain about how to undergo the process and how to do analysis in ANSYS, everything. Okay, friends, we complete with this. Bye.